Assalamualaikum and hi. We from Group 3 will explain about our assignment entitled Conduction Graphical Analysis on Heat Transfer. So, let's watching this video. Assalamualaikum and hi. Our introduction is we were tasked to create two different film surfaces and we had to perform a heat transfer simulation process using the appropriate software on the film surface. After that, we will analyze which film surface is better and suitable for use. Films are used in a large number of applications to increase the heat transfer from surface. Typically, the film's material has a high thermal conductivity. The film is exposed to a flowing fluid, which cools or heats it, with the high thermal conductivity allowing increased heat being conducted from the wall to the film. The design of cooling films is accounted in many situations, and we thus examine heat transfer in a film as a way of defining some criteria for design. So, for more detail on this assignment, let's hear from my other friend. Let's go.
Based on question, we are asked to make two different films according to the group creativity. The first film surface is flat film table. We choose stainless steel as a material on flat film. If we can see, film base is a flat shape, and the size of film is wide is 172.8 mm and the length of the film is 300 mm. The second film is longitudinal film tube. The material used is the same as a film flat surface, that is stainless steel. Film base is round shape and the inner diameter of this film is 50 mm for the inside diameter and 55 mm for the outer diameter. The surface size of this film base is the same as the previous film. The width is 172.8 mm and the length film is 300 mm.
I will talk about convection coefficient. What's meant by convection coefficient? Is defined as the rate of heat transfer between a solid surface and a fluid per unit surface area per unit temperature different. In addition, we must know the role of convection coefficient is imply lower pavement temperature and near surface air temperature. This is because more heat energy is transferred to the ambient atmosphere through the convection as air moves over the hot pavement. As we can see, we have two different types of surface, which the first one flat film table and the second one is longitudinal film tube table. For both different surface has a same ambient temperature, which is 30 Celsius, and the value of convection coefficient same, which is 6. This is because both surface same ambient temperature. If the ambient temperature is different for this surface, the convection coefficient value also different. Here we go to heat power. As we can see, for flat film tube has a flat surface above and heat come from that. For longitudinal film surface, the heat come from inside the rod. As we can see, inside the rod has a heat with a red color.
Now I'm going to talk about the average heat flux on cold side for both film. Heat flux, also known as thermal flux. Heat flux is the rate of thermal energy flow per unit surface area of heat transfer surface. Heat flux is the main parameter in calculating heat transfer. Heat flux vector is direct toward region of lower temperature. As we can see, the average heat flux on cold side for flat film and longitudinal film tube are the same, which is 700 watt per meter square. It is because the ambient temperature and material for both fins are the same.
Okay, next is temperature. Okay, based on the picture, number 1 is the first type of fin. The maximum of temperature is 154 and the minimum is 151. Okay, for the type number 2, the maximum of the temperature is 155 and the minimum is 152. Okay, for both of these simulations we have you the value of heat flux is 700, so the value of temperature that we get is higher. Okay, for next slide is we change the value of heat flux. For this we use the value of heat flux is 50, so we can see the change of the temperature. Based on the picture 1, the minimum temperature is 49.5 Celsius and the maximum is 56 Celsius, and the second picture is the minimum is 51.4 Celsius and the maximum is 58.7 Celsius. Okay, based on the simulation that we have do, we know that the value of heat flux will affect the temperature for the fin, and so if the value of flux is decreased, the temperature also will decrease.
In conclusion, it can be seen that design of the fin had significant influence on the fin heat exchanger, since it clearly impacts the performance toward heat transfer capability. The main concern on fin design is its effect on the behavior of the fluid flow. Quality of the fins is confirmed by the reality of the surface area of contact with the fluid. The bigger surface area of contact with the fluid, the better would be the performance of the fin's heat exchanger in dissipating heat. Therefore, the main concern with regard the quality of the fins is achieving the biggest surface area possible for the fins. It was observed that the main attribute that highly influenced the performance of the fins heat exchanger was the design of the fins. This is because the design of the fins would influence the fluid flow that serves as a medium of convective heat transfer as it passed along the heat exchanger. Performance variation was minimal and insignificant when the quality of the fins was changed. That's all from us. Thanks for watching this video.